This is a text-to-speech presentation. The original one was in Hungarian language. The text-to-speech software was from imtranslator.com.
I don't need to introduce myself, because Zoltan introduced me. I'm sure the product, the TMON, description and what it covers, is already known to many people, but I will try to tell in a few words what it is really about. It is mentioned in the main title, and in the title of this block, where we are not the only presenters, that we would like to make reference to Six Sigma multiple times. Now, without making any allusion to anybody, I am part of a generation that somehow did not yet learn the Six Sigma at school. Therefore, I consider it important to say a few words about it, those few words I know about it. So, Six Sigma is a concept that supports the appropriate product quality, the appropriate efficiency of a large organization, of a large company. Actually, I placed here only the figure that explains the name Six Sigma. So where does this name come from? A distribution curve is generated about the quality of the products, and this distribution curve is placed between -6 and +6, and depending on where the inflection point of this distribution curve is, it can be determined what is the sigma value they work with. For example, if it falls on 1, from the article I read it results that this means 69% errors, so that much falls outside the curve. To the contrary, if we would reach 6, which is actually the expectation so to say, then it would be 0.000 and some figures only afterwards. This is the error limit, from where we have to consider the production to be faulty. I try to tell about this, just to refer to the context we are targeting. We are talking here basically about an IT environment, about companies that aren't small at all. Their IT isn't small at all, where there are many participants, many sets of hardware and software need to cooperate, with all the related problems of these systems are of different age, have different availability, etc. So we can bring up plenty of reasons that can cause problems. We cannot ignore it all, the point of view that we need to strive to know exactly, not just approximately, what is the quality of what we produce, respectively to strive for this quality to reach an as high as possible sigma value. I would like to use a simple example. I'm not skillful enough to create such figures, this is created by my colleagues, but I think the example is very good, that's why I took it over. Let's imagine a group of applications where we have a portal, we have an enterprise service bus offering services, and for example an AS400 background system. The application itself is designed in a way that the transfer service available in the portal is done, actually by implementing two SOA services. Both are running AS400 code in the background. Now if we try to use these in a completely quasi-native environment, that is one that is built only on the listed software, then the request is performed, the portal itself is logging this, afterwards the service is called, ESB is logging this, ESB calls the AS400 function, this is logged, and this can be nicely clicked through like this. It calls the account balance query, that is logged as well, and then the result gets back to the user's screen. And, for example, this result is a huge exception that the user sees, and then she complains or not. How do we know in this system that some error occurred, in our case say in the service name balance service? Generally, we are not used to have a look at these logs, just so, lard pour lard, there's quite a lot of them. Say, if the customer decides to make a complaint because she didn't like something, then she calls the help desk. The help desk cannot say anything about this. Sooner or later, the problem gets to the system administrator. The system administrator starts to look at these logs, and through a lengthy work reaches the conclusion that yes, the error is in the ESB layer. Now, I think, we don't need to have a very big imagination power to recognize what happens If this is a very complex, very complicated environment, we have seen in the presentation of Susan Antle, what design and development mechanisms are followed by Ray Feisenbank, for example. If quality is what the customer perceives about the open service, and that can be solved only on this level, then this is very far from any Six Sigma concept. Now, we have a product called TMON, and it isn't very young, and it is used in several places. There are some participants who use it. Let's imagine how we could improve the quality picture we would like to achieve just by using this product, and possibly not touching anything in the current architecture. So practically, we don't touch anything, everything works as earlier, and let's imagine say the same process. The essence of the process is that we place an agent next to each log. The role of this agent is to produce about the given event some message that can be processed by our system. This is our system. The component that receives these messages is called build log, and this one inserts them into a database. Now it does not have such a big importance from our presentation's point of view, but it is easy to observe that we are only writing 2 columns in this database. The end will be that sooner or later, it calls this service named balance service, and that will give an error. The error gets out to the log. The agent reads the log, and sends it to this build log. As a result of this, we are marking with red the rows in our database that refer to an error. So if we walk through this cycle like this, and it is finished, then we don't need to wait for the customer to complain. Instead, we have exact information in this database that this transaction was not successful, and the reason for non-success is that the balance service ran on error. Now whether we handle it or not, that's another question. But if we want to handle it immediately, practically online, that is when the transaction was unsuccessful, then this is already given in this database. Not only the database and the insertion part belong to TMON, there is an interface belonging to it, the TMON interface, on which for example such erroneous lines appear immediately in such nice red, so somebody can observe it through this. On top of this, and we will come back to this in a few words, it can be taught to send an SNMP trap to any tool that can process SNMP traps, that is, we are able to notify other systems as well. Previously our idea was to process the logs using agents. Well, it doesn't require a very deep IT knowledge to realize that if there is an AS400, an ESP implemented in Message Broker and some very exotic portal server running on a J2E platform, then their logs are not completely equivalent. Their structures are not the same, and this poses certain compatibility problems. So it is true that the solution is quote-unquote cheap, but these agents have to be written. So we don't need to touch the applications, everything can be used as before, but we have to write such agents. The solution, the so-called direct logging, starts from the fact that we are thinking of it already when planning, implementing, that is developing the applications, so we are thinking about it in the application, that it should be able to send such log messages to the system. This supposes that we touch it. We develop the application in a way that it can send these log messages. The thing is performed the same way, just that we don't handle the logs now. Instead, the portal itself sends the message. I don't want to waste much time, let's click it through. The result will be that due to the error the red stripes appear here in the SNMP trap in the TMON view. Here we can see 3 columns. The difference between the two is that in the previous solution we have no guarantee with those agents to be able to ensure that data belong together. The role of the different components, the fact that the transfer service and the balance service belong to the same task, to the same process, it's not sure at all that there is a possibility for this. But here we talk about a conscious logging. Here it can be clearly expressed that this is a process consisting of this many steps, and this step require this many messages, that is such log messages. This is actually the so to say original configuration of TMON. So this is what we have to know about the system. It starts from the fact that the applications are either logging directly, or performing the logging the indirect way. This would be the architecture of the TMON system in a very simplified way. Just coming back to Six Sigma in parenthesis, so if we start from the fact that we are thinking about supervising an architecture. For example, the deposit administration project in the presentation of George Tokovitz, that contains fairly simple operations making a deposit, breaking it, but there are more complicated ones, with many participants, many components, and we want to achieve Six Sigma results, and I will tell you, I hope I don't forget it, a few such results, then definitely the combination of the two solutions is recommended, so both the one using agents and the direct logging. So what would be our current architecture? This is a part of the build log that can receive the logging requests coming from the source systems. In a very simplified way, this is actually prepared to receive WMQ, JNS messages. These messages can come from different sources. The most fashionable in today's world is to call a web service. This has an interface, and we pass the data to it. There can be applications that cannot call a web service because they are using a technology or are running on a platform where this is complicated or even excluded. In this case, we can work simply with MQ or JNS messages. And we shouldn't forget these agents. Two of them are listed here. One is the agent processing a log file, for example a log4j. This is called an appender. This forwards the log4j entries, where the configuration enables it, to the system simply as MQ messages. The other one is the CEI. We have to know about this, that for example the specialty of the IBM workflow engine, that is the process server, is that it can generate such CEI messages. These messages are meant for the business process monitor, from where nice KPIs and all sorts of other reports can be created. Then we thought that if these messages already exist, why wouldn't be able to tap them? So if they contain information from which we could write very good logs in our system, then we catch them, log them, and then of course we forward them without change to the original addressee so that it can also utilize it. The list could be longer. Whoever participated in more such TMON presentations held by myself or by my colleagues, they know that we have also utilized different other solutions. The build log itself works in a database. This database has a current structure that we would like to change soon. The build log itself is able to recognize if the log message has a context that it possibly needs to send an SNMP trap, so the sending of this trap is performed already at this level. There is a TMON interface belonging to the DB interface. Anybody can view them here. And finally there are statistical proceedings. These statistical proceedings can be very useful generally, and I don't only mean Six Sigma here, and I would like to present a few examples. Before the examples, I would like to highlight that there are currently 3 of us at T-Logic working on this project, and both colleagues are here, Theodemy Anemish and Stephen Hrvat. And those who used to know us for a long time know that Andras Nej and other colleagues have also worked on this project, so this is not a project that the 3 of us have, so to say, put together in 5 minutes, but this is a project that requires large efforts. With regards to statistics, I'd like to say that requirements arise everywhere. They have arisen at each of our clients. This is very nice and very good and very pretty, and it can be filtered this way and that way, but I would also be interested in. And then they tell something that we are not sure we can create offhand, so let's do it by creating an SQL view for it. And if that SQL view is already created, where could I view it? The most natural way is to view it on the TMON interface. So we have to provide the possibility for this tool to be easy to solve and use for everybody, and we can show even the views that were originally not thought of, not planned by us. This is how the interface looks like. This hasn't changed a lot lately. You have to know about this, that in reality this is an applet. Maybe everybody is wondering now, but the fact that it is an applet has a lot of advantages. Let me tell you in a few words how it is structured. In the left panel we can see the processes. If we think back to our previous example, there we say that the transfer and the balance query are processes. A row in this panel corresponds to this process. Let's say the one that is selected. If we click on that row, then here in this upper right panel the steps that were logged to that process will appear. What do we refer to here? Portal, ESB, AS400 system. Everything appears twice because there were two processes, so the ESB logs twice, and the AS400 logs both times too. If we select a row here, and we double-click on it, then in the lower panel the imprint of the primary messages will appear, the ones that carry these log messages. The slide is not expanded that deeply, but here if we click the right button, then the original message itself can be viewed in such an HTML window. For the lower left part we can say in a very simplified way that two possibilities are offered. One of them is called Quick Filter. These quick filters can be freely configured, so it is not a must for everybody to have such a quick filter. It can be something else. There are some very trivial ones that are good to have anyhow. One is to be able to delimit what is the time interval within which the information is interesting for us. The other is, for example, to be able to set that we are only interested in those having an error status. So if somebody's task is only to monitor the errors, then only those statuses are interesting. And at the very bottom there is a quasi-full filter that has to be interpreted in a way that a query can be composed very simply from the columns of the given panel replicated in an SQL table. This can be done graphically, so it needs minimal SQL knowledge, and then here in this panel only the rows corresponding to these conditions will appear. Now, there is a menu option related to statistics where we can select that now we are not interested in all three panels but only two. Then we can, for example, extend the filtering to the other panel. Then we can view prefabricated statistics that contain, for example, information on what transfers there were on a specific day. So we want to extract information only on these transfers that we had at the beginning of the show. For example, what was the average execution time and similar information. Let's consider these as, so to say, recommendations. What events are supposed to or used to be logged? Usually we log the entry and exit points. This is very important if we want to acquire information like how much time did the execution of something, for example a service operation, take. So we will not be able to extract this from the system otherwise, only if we log these timestamps. It is very important to log each error. I think we don't need to dispute this. The others are also important. The essence is really the bottom line. All this has to be planned. So it's not that easy to just say, okay, we place it there, then we will log something, and then something will come out of it. All this needs to be planned, and this planning has to be done on the level of logical system design. So I don't think it is a good practice if the developer deals with this. If the developer designs it, this work is already so much distributed during the development, so many people specialized on different platforms work on it, who don't really oversee the entire process, they simply don't have the chance to do it right. Now, the practice, that we will check at the end of the development how the logging succeeded is not a successful practice in my eyes, because we always establish, this didn't succeed very well, but nobody will remedy it because it's very expensive, very costly, let's leave it like this. So, that's why I consider it very important to perform this already as part of the logical system design. Another problem, that is, so to say, not observed at the first sight. Think again to our first figures, there is a portal, there is the ESB, and there are, say, the background systems. We agreed that everybody is logging. So they send the logs here, by calling the logging service. But what will ESB log, for example? How will it know, when logging about a given service, in which process it takes part? It will not know. So if it doesn't receive here through the interface, where I place the question marks, so through the service interface, those very minimal necessary information, then it doesn't know that it was called now by this one, now by that one, now by that other one. We need to be able to differentiate these instances. For this there has to always be a set of information, we call the context, that needs to be added to the interfaces in order to ensure the continuity. What are these information? Descriptions are quasi-historical, so their importance is low, and they don't correspond to the current interpretation. If you think back to the TMON, interface figure, there were two important panels, one was the processes and the other was the process steps. We differentiate the types of these using the ActionID, module ID identifiers. Obviously these need to be unique, so if we say within the organization that this is a transfer, then a process identifier needs to be created that refers to the transfer and cannot be mistaken for anything else. Similarly, since the transfer consists of two services, when we figure out a name for one of the services and a name for the other one, these have to be unique. We have to be able to identify the process, respectively the process step, not only as a type but also as an instance. Therefore we use this root id for identifying the process instance. This particularly has to be a unique identifier within the organization, because we need to differentiate and see everything on that single interface. And we use the request id, that is less demanding in terms of uniqueness. We identify and differentiate the components with this. The heart of the whole logging is that we should always log a timestamp, respectively a status. So these are the information that can be expected as a minimum to be logged, and we always have to imagine the first four as something to be handed over to the context, to the one we address, so that his logging can be connected to the previous logging. I would like to proceed to what our plans are, without going into very much detail. All this refers to the fact that the processes implemented in process automation software, for example IBM Process Server, are more and more widespread. These processes launch or call subprocesses, and for example these subprocesses have very different execution times. One of them runs a few minutes, the other may last even for a week. In our current data model we can't really mark the subprocesses belonging together, so which is the process, which is the first process, which is the second process, we could only do it if all had the same root id. So simply an identifier is missing, that could tie together the subprocesses identified by the root id belonging to the process. We need to add a new column to our base model, that refers to the parent process, so if I am for example the fifth called subprocess in such a tree structure, I don't need to point to the main process, I only need to always point to the parent, and based on this the whole chain may set in sooner or later. Why is this needed partially? Let me tell you an example related to crediting. I have a sub-process, I have started say after 3 days, and the objective of this sub-process is to determine whether the given customer, who requests a credit complies or not with some prescribed KO criteria. This will influence not only the sub-process, so it is not enough to determine that this customer may not receive credit because of the KO criteria. This information needs to be traced back to the most important parent process, which will lead to the rejection of this credit request. So it is necessary to be able to set the status of parent processes. What other modifications are we planning? Integration with TCPS is already working. This enables us to delimit using TCPS for each role who can access which column. In practice this is not yet enough, we need a few more really important things. I'd start with the base filter. So there should be a possibility from start to set for a certain role, that she may see only this and this information. For example, if she is somebody administrating say a credit system, then she has a base filter that enables visibility only to the credit system. She shouldn't be able to override this. So all the filtering and other trickery she can set should happen within this. If we have this, then we can set using TCPS the content of which columns she can view in her role. Because we don't only log ActionID, module ID and such things, but we also need information that identifies the transaction from a business point of view, so for example who was the client. For example, in case of a customer complaint arriving to the help desk, the customer doesn't know the root ID and the other identifiers, she just knows I am this and this is my account and I wanted to do this at this time. So such information is needed, but many times information that are specifically confidential get in during the planning, so it might be necessary to filter for these. We need an administrative interface in order to implement this, one where we can set this, because this assumes that we want to set up profiles corresponding to very strict rules. Practically we can do a lot of things right now, but it can be solved only by executing SQL commands, respectively editing XML files. So there is no elaborated administrative interface, we have to think about it and implement it. Also, we'd like very much to enable the regular user to create views herself, ones that she needs, from the information she can access. This is currently always done by some specialist, so not by the user herself. Maybe it's a little bit obsolete, but we deal with this software for many years now, and I'd like to highlight once more, that it's not enough to use the software. If we think back to Six Sigma, it's not enough that we want the good thing, and we do certain things for it because the regulation prescribes it. If the goodwill in complying with the regulation doesn't lead to results based on which we achieve the necessary goals, then this is probably wasted work. Again, I'd like to say with this, that whoever begins the work with this should think these through basically at the planning, and then we will have a very elegant and very good tool.